Assalamualaikum and hello everyone. Welcome to a new video for 2.3 electronic configuration. In this video, what we're going to look at is actually predict the electronic configuration of atom and monoatomic ions using spdf notation. Monoatomic tu, it means that atom tu mesti ada satu lah, monoatomic ion. Okay, so we're going to look at is actually on page 19. So right now we're going to apply all the knowledge that we have learned previously into determine the electronic configuration of a given atom. Okay, but then before that, let's look at example here. Example on page 19 ni, mention that determine whether the following orbital diagrams are acceptable. Explain the mistake and draw the correct orbital diagram. Again, this is actually your orbital diagram. So dalam example ni, for the orbital, label it above the box. Kalau nak label bawah pun, it's fine. Okay, before we're going to look further into the question itself, let's do a bit of recap what we have learned from the previous video. So there are 3 rules that we have that we must follow to in order to write down the electronic configuration. Firstly, from the Aufbau principle, it mentioned that the electrons must be occupied in the order of increasing energy. So 1s, 2s, 2p, 3s, 3p. Okay, here is a bit of different. We're going to fill up 4s dulu, then baru 3d. Okay, why? Later in the next video, I'm going to explain it further. Okay, next rule that we're going to look at is the Hans rule, where the electron must be filled singly before pairing occur. So for a given, for example, untuk p orbital and d orbital, make sure the electrons are filled singly first. For example yang ni lah. Then can the pairing occur? We can't do yang terus pair up macam ni. We must fill singly. Okay, last but not least is the Pauli's exclusion principle. We have mentioned that actually the electron have different, no two electron can have the same 4 quantum number. Another name for it is that for the electron in the same orbital, it must have opposite spin. So if not, if it is the same spin, it means that all the 4 quantum numbers too is the same. S mestilah opposite. S must have the positive half and S must have the one for the negative half. So that's why this is correct and this is incorrect. So that is the summary. So now let's look for the examples itself. Okay, example number 1. Okay, so here is given the orbital diagram. So here we have 1s. Okay, it is filled and the electron is in the opposite spin. The same goes for 2s. And then for the 2p electron, it is filled singly first. It does not pair up. So this one, it does obey the Aufbau, it does obey the Hans rule, and it does obey the Pauli's exclusion principle. So for this one, it's actually acceptable. Okay, next one. For example number 2, so we look here, we're going to fill 1s first, and then make sure the electron must be on the opposite spin. Okay, and then for the 2s here, okay, the 2s is filled, but then it does not, it has the same spin. So remember, no 2 electrons can have the same 4 quantum number. Sebab yang ni, nanti both ni s ni equal to half, positive half. So nanti sama, dia tak, elektron ni setiap satu dia unique. Okay, so yang for the 2p ni, it's correct because it is true. It must, based on the Hans rule, the electron must be filled singly first. Okay, so what we're going to do, we're going to write down not acceptable because it does not obey. Okay, it does not obey Pauli's exclusion principle. So we have to write down the correct one. So the one yang correct, what we're going to do, ini kecilkan sikit. Okay, so start dengan 1s. So even though it's incorrect, but then we have to write down from the start lah. 1s, 2s, 2p. Okay, 2p. 1, 2, 3. Okay, even though for example, contohnya dekat sini as we can see, 2p, it must have 3 orbitals. So even though dia diisi ke tidak, but make sure that for the p orbital memang kena ada 3 lah. We must have 3 boxes ataupun the 3 platform ni. Yang ini kita panggil ni sebagai platform. 2, 3 ni. Even though it's not filled, tak apa. Paling penting kena ada 3. Okay. Yang ini, yang last one. For the question for number 3 ni, kita tengok. Okay, yang ini. 1s pun is not filled. So, first and foremost, mestilah in order of increasing energy. So, dekat sini, does not OP. So, first one, dia punya Aufbau principle tak OP. Next is Hans rule. Okay, yang ini pun sebenarnya Hans rule pun tak OB juga. Sepatutnya it must be filled yang dekat sini dahululah. First yang for the first boxes ni dulu. Okay, and then yang Hans rule poly tu betul sebab memang all the electrons have the opposite spin. Yang pair up ni it has opposite spin. Okay, so yang ini nak copy paste ni jap, not acceptable ni je. It does not OB. Yang ini does not OB Hans rule and does not OB Aufbau principle, and then it does not OB and Hans rule. Okay, so what we're going to do next is actually kita buat, okay, so kita tengok electron ni, how many electron is there? 1, 2, 3, 4, 5, 6. So ada 6 electron. Okay, so first start dengan 1s, 1, 2. Okay, 2s, 1, 2. So it only has 4. So next is actually 2p orbital. Okay, remember, even though the electron is not occupied, make sure kalian tulis lah. Jadi kalau 3D kan, jadi dia 3D one, but then you have to draw the 5 orbital ataupun 5, 1, 2, 3, 4, 5 macam tu. Okay, so again, this is 6 electrons, so we already have 4. Make sure electron dia 1, 2. Okay, so that is actually for example number 3. Number 4, 5, 6, I believe you could try yourself. Yang akan nanti Miss masukkan, includekan the question in the quizzes. Okay, so that is for the first example. Next example that we're going to look at is actually here. Write down the electronic configuration of each atom in terms of orbital diagram and SPDF. Okay, so remember, for the electronic configuration, it must depends on the number of electron. Okay, but then we do not have the information for number of electron, kan? What we're going to look at is actually based on our table of constants. So depends here lah. Remember, dekat proton number kat sini It's not the end, it's not the fourth one, yang the third one. Okay, so actually yang ni because I have remembered it. Okay, so here I'm just gonna labelkan the number of proton. The number of proton tu I label as Z. Okay, so carbon ni Z is equal to 6. Here sodium is actually kan, so it's actually 11. Okay, so sulfur is actually ada 16, betul tak? Tengok sekejap. Sulphur, 16 here. Okay, so now let's look for the example itself. Okay, they ask in terms of orbital diagram and SPDF, so we have to write down both. So for the carbon, okay, remember, first we're gonna write down, okay, so carbon 16. So carbon 16, carbon 6. Okay, so first I'm gonna write down SPDF dulu lah. 1s2, 2s2, 2p2. Okay, and then for the orbital diagram, 1s2, 2s2, 2p2. Okay, so again remember, even though the electron is not filled, must draw the 3 orbital lah. And then for the orbital diagram, you don't have to write down kat sini 2 ni tak payah. Tu rasa macam nampaknya you overdoing it. So that is it. Okay, remember memang 1s sebab when n equal to 1, n equal to 1 memang l equal to 0 sahaja. So there's no more. Okay, so memang 1s lah. Yang 2 pun memang sampai 2p sahaja. N equal to 2, l could only be 0 dengan 1. Okay, and then remember for the s orbital memang maksimum dia 2 electron. Okay, kalau p maksimum dia 6. Kalau d orbital maksimum dia kalau d orbital maksimum dia is 10. If you be unsure, boleh tengok first video balik. Example number 2. So sodium. Okay, sodium, if you be unsure what is actually the symbol kan, boleh tengok list of constant. Okay, sodium, I believe is mana? Okay, sodium. Ni Sodium, the symbol is actually Ne11. Okay, so Ne. So dekat sini, so it means that 11 Ne. So 1s2, 2s2, 2p6. Okay. So memang n equal to 2, L could be 0 and 1 saja, which is 2s2p. Okay, so yang ini 2, 4, 6, so 10. So we have another one. So dia akan jadi 3s1. So 11 sodium, 1s, 2s, 2p, 1, 2, 3, 4, 5, 6. Okay, then 3s1. Okay, so that is for our sodium. Okay, next is actually sulfur. So sulfur is 16. Okay, so kita tulislah 16 sulfur, symbol dia 1s2, 2s2, 2p6, 3s2. So here baru 2, 4, 6, so 10, so here 12. So we need another 4 more electrons. So 3p4. So I'm going to write down the orbital diagram. 16 sulfur, 1s2, 2s2, 2p6, 1, 2, 3, 4, 5, 6, 3s2, 1, 2, 3p4, 3p, 1, 2, 3, 4. Okay. So, that's the end of the example. Yang 4, 5, 6 tu, remember, look from the list of constant tu, it must be depends on the proton number, bukan relative atomic mass. So, we have looked for the example for the neutral atom. Right now, we're going to look at for the electronic configuration for the monoatomic ion. So, ion, it means that it has charges lah, be it positive or negative. It could be cation or anion. Okay, so on your notes on page 20 ni, so let's look here. So, for the electronic configuration for ion, what we're going to look at is actually we're going to start with electronic configuration for neutral atom. And then, we're going to plus or minus the number of electron, depends on the charge. So, what is the difference for the cation? So, we know that it meant by positive ion lah. And ion, negative ion. Okay. He mentioned a positive charge ion form when a neutral atom loses an electron. So, for example, sodium ni, the number of proton is 11. So, number of electron dia sama lah because it's a neutral one. But then, when it form cation, positive, sodium positive, so what happen is that you're going to lose one of the electron. So, the number of proton is the same, but then the number of electron will be less than that. So, minus. Cation ni will be less electron. So, I'm just going to write down. Kita akan less electron. Whereas, kalau anion terbalik pula, we're going to gain electron. Okay, so for example, chlorine. So, for the neutral one, it's a 17 proton and 17 electron. But then, once it become an ion, Cl negative, it means that it accept one electron. So, bila it accept one electron, so it means that the electron increases from 17 to 18. Okay, so right now, let's look for example number 1 dengan tu kita buat sama-sama. Example number 1 ni, it's magnesium. So, what is actually the number of proton for magnesium? Kat sini, ni manganese ni. Magnesium, Mg, so the number of proton for neutral one is 12. So here, okay, magnesium ni proton number dia Z is equal to 12. Okay, so what happened is that for the proton number of magnesium, I'm gonna write down. Okay, magnesium 12. So it means that 1s2, 2s2, 2p6. Okay, so it got 2, 4, 6, 10. Okay, so we need another 2 more. So, dia jadi 3s2. Okay, so tu yang first one lah. But then, what happened is that right now, it is actually 12 magnesium 2 plus. So, what does it mean here? Maknanya bila dia dah 2 plus, it donated its electron. Dia donate electron dia, 2 of the electron. So, bila donate electron, dah tak adalah 3s2 ni, dah donate. It will donate the electron yang paling jauh, yang paling luar dulu. Dia bukan donate from 1s2. It donated from yang 3s2. Okay, because why? Contohnya kita ada shell 1, 2, 3 ni kan. Okay, so when the electron dia n equal to 3, so it means it is the furthest away from our nucleus. So, the attraction between the nucleus and the electron itself is very weak. So senanglah dia nak donate the electron. So that's why we're gonna donate start yang bila n equal to 3 ataupun from the question itself yang n yang paling jauh sekali, yang the highest n, sorry. So kat sini dia akan donate yang 2 electron sinilah. You will donate from here sebab 1s tu maknanya itu yang paling dekat sekali dengan nucleus kita. So attraction is very strong. So dia akan donate 2 electron from here. So dia akan jadi 1s2, 2s2, 2p6. Okay, so itulah dia. Okay, so usually for the case of electron ni dia nak donate ataupun gain electron, it happen when it want to achieve octet. So contohnya kalau kamu tengok dekat sini, ni sama juga kan dengan 2, 8. Kalau yang ini sebenarnya 2, 8, 2. So what happens is that sebenarnya bila it want form an ion, octet ion ni, is that when it want to achieve octet. Octet tu apa? It means that gonna achieve 8 electron lah in the outermost shell. That's the case for our cat ion, positive ion. Okay, what happen next? Alamak, kat sini tulis je lah Kalau positif, maknanya kita akan lose electron. Okay. Next, we're gonna look for the case of N ion. So, N ion ni is actually our, kita buat kat sini number of proton. Number of proton is fluorine is 9. Okay. Kita nak confirmkan balik F. Bahaya cakap F macam tu je. Okay. So, Fluorine here it's 9. Okay, so Z is equal to 9. Okay, next is actually N ion. So N ion, what happened is that for the negative one, negative ion, it will gain 1 electron. Dia akan tambah lagi 1 electron. So contohnya for 9 fluorine, okay, we start with a neutral one. Kita tak nak tengok charge lagi. So, maknanya number of electron pun is 9 lah. Okay, so 1s2, 2s2, 2p, 5. Betul tak? 2, 4, 5. So, it's 9. Okay, so sekarang ni, it's actually F negative. So, it means that it gain 1 electron. So, bila dia gain 1 electron, maknanya kita akan tambah lah 9F minus. Yang ini masih lagi 9 sebab yang ini kan sebenarnya number of proton kita. So that's why lah, walaupun number of electron dia berbeza, tapi number of proton dia still 12. So that's why dekat sini Miss tulis number of 12, sini masih lagi 9. So what happened? It gain electron. So dia gain electron, 1s2, 2s2, 2p6. Okay. Satu sebab kat mana lagi nak gain kan? Yang ini dah failed, ini pun dah failed. So yang ini pun dah outermost one. Lepas tu bila kita tengok balik kan, kita just check. Yang ini kan 2.7, ni dah win octet 2.8. So that is actually bila kita nak jadi the N ion and cat ion, what happen is that bukan suka-suka nak donate, bukan suka-suka nak accept, is that because the atom itself try to form octet lah, sebab yang itu yang paling stable arrangement. Okay, so for question 3 and 4, I believe you could try yourself. I think I'm gonna add in some more question during the quizzes. So that's the end for this video.